Hola, Putney. All right. Can we just take a deep breath? All right. Good morning, Putney. I'm so happy to introduce the first exhibition of the day. Foreseeing an exhibition that is leaving a positive trace on the community, it warms my heart. It's been wonderful to see Skylar's journey from a dream that transformed into, well, I'll say, a fixed idea that later evolved into a larger project that is now an extremely welcoming place, quoting someone. His impact, I believe, is the beginning of a larger story. When Skylar came to talk to me about the exhibition idea, I was like, And I was just trying to get a sense if the student was hoping to do this out of a sense of duty, because you started a project, you need to continue with this. But I remember these words, I really, really want to do this. I can't believe that we are here in the presentation day. So before we hear about Skylar's journey, I want to introduce the two reviewers that we have for this exhibition. So we have Madison Dunaway, director board member at Hatch Space, among other hats, I believe. So she has over 10 years of experience building community spaces designed to foster design, fabrication, interdisciplinary collaboration. She started maker spaces and fabrication labs at UNCC, Wharton College, Boston College, and now works at Dartmouth College. Sorry, guys. She leads a maker meetup group in Boston that meets monthly to discuss crucial conversations and have been published at, oh my gosh, what's happening with me? ISAM and DIS, and also consults for makerspaces and fabrication labs around the world. We also have a shop leader from the Hatch Space as well, Rowan Norlander McCarthy, and I bet this is also one of the many hats that Rowan may wear. And Rowan is a cabinet maker driven by curiosity and the pursuit of quality. He believes that in melding the industrial, applied, and fine arts, we'll have the opportunity to live in a more harmonious, sustainable world. A lover of trees, from seed to stump, when not at the shop, you'll find him at the forest or in the garden. So thank you so much both for being here. And well, without further ado, Skylar, the mic is yours.
Thank you so much for the lovely introduction. Can everyone hear me all right? All right, thank you all so much for being here. Unfortunately, I woke up this morning feeling a little bit sick, and luckily I felt that coming on, and I planned ahead. So today I have a video of my presentation that I want to share with all of you, and then hopefully at the end I can come up and answer a few questions. All right, I'm going to pass it off to a less sick Skylar. Thank you. Good morning, everyone, and thank you for coming to my presentation. Today, I'm going to be telling the story of the Putney Makerspace Initiative and how those efforts have culminated in the last 3 months of my exhibition. But first, I need to say thank you. Thank you to Rosie. Your level-headed approach to project management and knack for organization is what has gotten me through this project. You saw the vision I had and expertly guided me through the process of making it a reality. I am so grateful. And thank you to Bryce. You've put so much of your own time, thought, and energy into this project, and it has made a world of difference. And thank you for teaching me everything I know about carpentry. It is a skill that I will take through life. And thank you to Dawn for all of your support throughout this project. And finally, thank you to my outside evaluators, Madison Dunaway and Rowan Norlander McCarty. So, for those that are not aware, this is the Makerspace. I've worked for the last 3 months to build this, and it is here for all of you to use, and well, build anything you want with it. So I want to start off this presentation, as any good aspiring engineer would, by establishing some goals and some constraints. So I'll be upfront. My goal today is to inspire all of you. I believe that that is a role of a good exhibition and what I hope to do. There are some problems with that though. You might not know what this space is, how it came to be, and why it was built. So let's start with how the vision of a couple of sophomores turned into a major project. And if we go up to the 30,000-foot view, that happened through this, the engineering and design process, which is all about breaking down a complex task, like overhauling the Putney Makerspace, into smaller chunks that are more easily understood and executed. And there are phases to this process. At first, it's all about asking questions and imagining solutions. And then it becomes all about turning that vision into a thought-out plan, carrying through on that plan, and creating the first prototype. Then there's this final section about performing tests, evaluating the prototype, and improving it. So Rye and I came to Putney in our sophomore year, and we found 3 3D printers, and none of them were working. So we fixed them. And we did this because we had a passion for this and wanted to share it with the school. And at first we asked many questions about how we could do this, and we got all of the answers wrong. But we had the first step right, asking questions and seeking to solve problems. We solved this problem. The Putney School had tools that could be used for students on a myriad of really interesting projects, and yet there isn't a space for them and they aren't being used or taken care of. So the question we asked ourselves was, how do we fix this? And the answer was obvious. We build a home for it all. The trick was figuring out what needed to be built. So I like calling this next phase research, trying to answer that question of what needed to be built. But of course, this being Putney, we did that experimentally, and we didn't actually know we were doing it at the time. We were just using the space, but that was the best way to understand what needed to change. And we used that understanding of what was necessary to refine our vision for the future. At the same time, the need for change grew. More classes and students began to take part in what we were doing, and it was really encouraging. And this past fall is when the project really became more formalized. I think student projects, we all agree, are the best kind of projects, but they also need stability, and that's where Rosie came in. She stepped up to head up the Makerspace project on the faculty side. And this is something that really felt like a privilege, to have the school recognize our work and what had been done and want to continue it in a more serious way while keeping us as an integral part. And what emerged from that was this really beneficial collaboration. As the project became more serious, it was time to get creative and start imagining what it would look like, how it would function, and how it would fit into the school. And that really took the form of establishing our design goals. So, we wanted a home for the machines that would be outside of the classroom so that they could be used by other classes for projects, and also generally to convey that these machines didn't just exist for the fabrication of mechanical parts for engineering or science applications. That, and we also wanted something that would last, so that when the next batch of students came, that these machines would be taken care of and have a home. Also, for it to be accessible. Everyone needs to feel comfortable and encouraged to use it. And I knew this would need to happen in 2 ways: the physical design of the space, and also the more human factors. For instance, the experience of learning to use the tools. It also needed to be nicely designed, in a way that doesn't feel unfinished and yet has room for expansion. And it's organized so that you don't feel like you have to carve out a space for yourself every time you want to work. And it is designed not in a way to constrain future expansion, but in a way that encourages it. This past fall, I spent Project Week building the main table. This was really my introduction to carpentry, and also when I began working with Bryce. Up until this point, I had a lot of experience making things, but in a very digital way. And working with wood was new, and I could immediately tell that the whole process was different here. And what I love is that your final product is as much a result of your initial idea as it is all the mistakes you make along the way. So building the table was really a proof of concept. And what I'm so glad is that this Project Week went well, because it set this whole idea in motion. And I finally felt like I could see how this idea I had for years would come to fruition. So building the tabletop was all about doing the glue up in the beginning, assembling the frame, cutting the legs, and finally installing it in Reynolds Hallway at the end of Project Week. So when it came for day 1 of the exhibition, standing around the table I had built with Rosie and Bryce, I came to the plan that would be executed throughout the exhibition. I had this vision for making more traditional style shelving and a number of other ideas for the space, and I was dead set on these. But Bryce had some fantastic ideas about how to accomplish our design goals, which we in the end all agreed upon. So through this conversation, we came to our finalized plan for what the makerspace needed to have. It needed to have a dedicated home for the machines. We wanted to accomplish this through a modular French cleat shelving system. And then there would be a central computer to control all of the machines, and overall, it would be a nicely designed and organized workspace. So, day 2 of the exhibition through about yesterday. It's been all about design, build, and motion, and this cycle of implementation and adapting the design. So let me walk you through those elements. It began with the initial infrastructure of putting up the plywood panels on the wall. It was really important for mounting things to. It helps to visually distinct the space from the rest of the hallway. So this was all about removing the wire mesh paneling that was along the hallway and replacing it with plywood panels that would be stronger and look a lot nicer. So then there's the cleat system. French cleats are an easy to make and use modular storage system, which lets the makerspace be modified continually into the future. They work using 2 interlocking 45-degree angled boards, and I would put special attention to the stain I used on the cleats so that they would be visually distinct from the plywood behind and they would be more recognizably a part of the makerspace. So another part of putting up the plywood was removing the table and all of its components. And this gave me a moment to consider the feedback that I had been getting about the height of the table. I had built a table which many people consider to be a Skylar height table. The tabletop was 40 inches off the ground, and that was something that didn't feel comfortable for everyone to use, and it became clear it needed to be changed. So I was able to lower it down to a 36-inch high tabletop. And I think this is a great example of the engineering design process. I heard feedback from people, I thought about what a solution could be, tested that solution with a number of people, and finally decided upon it and implemented it. So, with the shelving for the printers, I really wanted to take advantage of the visual lightness that comes with the cleat system. In other words, give the printers the look of them floating. Now obviously they had to be strong and stable, which is why they connected 3 cleats, so they are simultaneously hanging and supported from underneath. Building the shelves was a serious process and probably the most intense part of this project outside of making the table itself. From the beginning, Bryce and I were thinking about how not to just make one of these, but to make 8 of them. So I approached it a little different than other parts of the project. Instead of making 8 of them sequentially, I repeated each step 8 times so that it would be consistent. I also used jigs and stencils rather than hand designing each one. So then there was the electrical and networking. This was all about bringing power and network connections into the space to hook up the computer, all of the printers, and any tools people would use. So there was kind of another engineering process going on here, and that was working with another person or with another team who was doing work as part of your project. So I had to build a connection, and I had to work with both the tech office and the electricians. I needed to convey my design and what they need to do, while also understanding their work and how the two would interact. And this is an example of a diagram I gave to the tech office showing them where the networking would need to go. Another thing that I've worked on recently is a new table for the laser cutter that would allow the necessary ventilation to be run up to the window. Having the laser cutter be connected to the computer and part of this network with a permanent Ethernet connection will really help to make it more usable in the future. And for the first time in months, the laser cutter is all set up and ready to be used, and it's here to stay. One of the last touches I did as the exhibition came to a close was installing the pegboard and ordering all of the tools that I wanted to have in the makerspace. It felt really good to get to this point in the project. I had been feeling nervous for a long time because carpentry is hard and things were taking a lot of time, and to get to the point where these main objectives had been achieved and I could put attention towards these details felt really triumphant. But everything isn't just physical infrastructure. So going back to our original question of what needs to be built in order to have a dedicated STEM workspace that exists outside of the classroom and to have a place to keep and use the 3D printer and laser cutter. All of these components that we've just gone over are all about addressing the question of what needed to be built in the space. But there's this other question about how to encourage people to engage with it, and that is really about the experience of people using the machines. It needs to be easy, educational, and reliable. So I reflected on that experience of myself and others with the previous iteration of the makerspace. I remember all of the hours of troubleshooting 3D printers, trying and failing to find a pair of calipers in Reynolds 3, and all of the frustration that I saw directed at the laser cutter. So the main goal was reliability. People needed to be able to use a 3D printer when they wanted and needed to without having to fix it. The laser cutter had to work consistently, and there needed to be tools for people to use. So the last thing that I've been pushing to get done is the computer. A part of making these machines feel like they are a part of Putney and what is being done here with the space is giving attention to how they will be used. At the start of this project, Rosie, Dawn, and I agreed that the school needed new 3D printers. We decided upon getting a fleet of 4 highly reliable and effective Prusa Mark IVs. Among a bunch of other nice features, they have the ability to be controlled through a wired connection. This means that the usage of the printers is now all directed through this one computer, which makes it easier for people to interact with it. Another really important part of this project was the creation of educational resources for students, teachers, and classes that want to use the space. Now, while this isn't completely done yet, and Rosie and I are still working on it, we're really putting an emphasis on teaching people not just how to use the machines, but how to maintain them so they stay nice and functional. And thinking about how we teach people to use the space in a way that feels educational and not infuriating. So there are all these elements of the project that we have just explored, and they all connect back to the original design goals. The school now has new tools and shelving for the 3D printer, not to mention an entire computer system and curriculum for the machines. This also connects to the goal of accessibility. It makes the space easier to use for everyone, and we even saw that process in action with the adjustment of the table height. Design and aesthetics have played a big role in this project. I believe that has culminated in the creation of a welcoming and nice workspace. And the cleat system and documentation I'm leaving behind will make it easy to adapt the space in the future. But that really leaves one last question. What is next? Let's now return to this idea of the engineering and design process. And there are 2 steps left, to test and to improve. Lewis and Calum next year will be taking on heading up the space on the student side, and they will be working with Rosie. And there is already a lot of momentum and interesting ideas for projects, including an evening art next year that Rosie will be running. But this is also where I need help from all of you. We have this through line of design build in our education, and I think you can see how that echoes the engineering and design process that I have just laid out. And what I think is cool about the Makerspace is that it was built using the same idea and philosophy that is meant to be practiced with it. But that only works if that engineering design process keeps happening. What I've built out there in Reynolds Hallway is a first prototype, and prototypes need to be tested. For this project to be a success, people need to test this out, use the 3D printers, and build stuff at the table. By interacting with the space, it will become clear what needs to be done next. There might be places where you see a problem that necessitates a solution, or you might envision a future upgrade. And that's what this project needs, and what I hope for from you, to keep this dream alive for the next group of students. All right, well, I hope everyone enjoyed that, and I'm happy to answer any questions that people have. Yeah, please.
Are you going to add more shelves with these higher up?
There are some ideas to do some last improvements throughout Project Week before I graduate to add some more storage shelves above the ones for the printers on the cleat system, as well as above the table, perhaps some areas to display student projects above the pegboard. Glenn.
Thoughts on how we might bridge the present gap between this work and the arts?
Yeah, I think that is critical to the success of this in the future. There are things that we have thought about, and I think there are things that we have yet to think about and need to explore. We've talked about having a temporary installation of a 3D printer in Wender to allow people to use it. And there's some applications with the Form Labs, the resin printer, in a lot of different use cases with art that we've talked about, like jewelry. But I think the most important way that has to happen is organically. And by having students use the space, I mean, students here are artists, and by having artists use this space, it becomes something that doesn't just belong to the world of STEM, but something, by this space being used by people who create art, by using the space, they will be creating art. And I think that's what needs to happen. I think it needs to happen organically through student usage and student ownership of the space. Devin.
Were there any ideas you had at the beginning of this project that changed or fell through?
Tons. That's probably the majority of ideas. I think, Rosie, you touched on this a little bit, but I had, in the beginning, a really rigid idea for what I wanted the final product to look like. And it looked very different than what I just showed today and what's up there in Reynolds Hallway. And that included a bunch of different ways to approach the shelving and a lot of just ideas that were different. And that process, that evolved a lot, just mainly through talking to people and understanding other ideas for the space and seeing what people wanted to have and what needed to be there and just continually evolving those ideas. Yeah, hopefully hopefully that answers your question. Samir.
Do you ever see this intersecting with astronomy in the form of like building telescope parts or mounts or tripods or anything like that?
I really hope that's something that happens. I think there's a lot of, I can immediately think there's a lot of places in astronomy where you need small little parts for things that break and there could be repairs, but more than that, I think that I don't want this space to feel like it just belongs to people who want to use 3D printers and laser cutters, and really that it is a workspace for all types of projects and all sorts of things that students want to build. So I really hope that someone who builds a telescope, who's building a telescope, uses the space, uses its tools to make that happen. Clarence.
You discussed how you have a modular sort of system for organizing different. Do you see different approaches towards organizing on that system, or?
I can envision a bunch of different ways to do it, but I really hope that people come up with other ways. I think the whole idea of the French cleat system is that it's really, really simple. And it opens up a ton of different ways that people could design stuff that attach to it. You can have shelves that stick out. You can have vertical boards that stuff hang off of, and a bunch of other ideas that I can't even imagine right now. And I think that's one of the things that's really nice about the French cleat system. I mean, it is just 2 3-inch boards separated by 6 inches, and you can create anything you want that attaches to that.
In my conversations with faculty and staff of color at Teacher of Color Conference nationwide, one of the common, not complaints, but like concerns that they have is that maker spaces in other institutions were not always welcoming or inviting to students of racialized identities. And I'm just curious to know what would you say or what would you imagine to make it more welcoming to racialized identities.
Yeah, and that's something that has definitely been talked about throughout the project too and considered. And I think that really comes down to thoughtfulness and care by the people running the space. And that the way that those educational resources are designed and the way that the space is designed physically is done in a way that is welcoming to everyone and is welcoming to everyone and encourages it to be used, and then that is met on the other end by the approach and care put into it by the students running the space. So I think that's something that happens a lot on the personal side, and how that first personal connection between a user and the space head is carried out. Danny.
If you achieve these goals of integration of a vibrant space that's integrated with other parts of the curriculum and is welcome to people of all identities, and really what you want to do is happening, what story do you think that will tell about the type of school? What does that say about the school we are and the school that we want to be?
I think of these kind of spaces as being a very modern concept in education, and something that is being talked a lot about right now and pushed at a lot of schools. And what I think makes this iteration of it very authentic to what we do here is that it did come from students, and that this wasn't something that the school advocated for and wanted to create and then reached out to students to ask for their guidance. This was something that students wanted to see happen, wanted to see created, and went out and connected with the school to make it happen. And I think that's how it connects to everything we do here. Gil.
The space is beautiful and well organized. How do you suggest the community keep it that way?
I think suggest is a great word, because that's about all that we can do. People make things here. People love to use spaces, and people make a mess while doing it, and that happens. And that's something that I think is best not to come to the approach of that's something that we're fighting, but something that we're trying to work with. And I think the way that you do that is kind of back to the idea of making something nice and making something that people want to use, and hopefully also making it something that people want to care for. And that every student who interacts with the space feels a sense of ownership of it, and therefore a want to take care of it themselves. And I think that's a very tricky thing to make happen and very easy to say. So I think that you have to back that up with also having designated people, the makerspace heads who care for it, and obviously some work on the faculty side to just push that message out and make sure that people feel that way and hopefully take care of it. Robert.
Let's see. With machine tools in the 20th century, the
forms that were easily generated were Euclidean forms. They were rectilinear or solids of revolution with optimal straight sides. A lot of prints fail to print. And they often fail to print because people are trying to make Euclidean forms when 3D printing with adhesion to the bed prefers an organic form, prefers rounded corners and so forth. And I was wondering if you had considered using your racking system for some interpretive material on how to make a form that is more likely to print correctly, to adhere to that.
Yeah, I think that's a great point. That connects into another thing that I've imagined that could happen with the project is that you could put up resources for people teaching not only the basics of how do you start a print and how do you do this sort of thing, but about different mechanical systems and different ways to use these machines in creative ways. But I definitely agree with you that people need to be taught how to use these machines, not just in the way of here's how you start a print, here's how you slice a file, but how do you work with the unique aspects of what these things can do? How do you educate people on that? Todd.
First, thank you, especially for the laser cutter. Thank you. I'm curious if you can foresee the weakness in your system. Where do you anticipate future heads of the space are going to have to spend a lot of time? This is kind of connected to Gil's question a little bit about a space behind a locked door has an advantage and a disadvantage. The space in the hallway has an advantage and a disadvantage. Do you foresee any weaknesses in your design?
I do. I think something that we're even trying to address right now is a pegboard full of tools is an amazing thing for someone sitting at a table using a space, but it's also an amazing thing for someone who is walking by a space and decides that they want that tool. And I think tools walking away, I've talked to a number of people who run shops at this school in different places, and tools walking away is the issue that plagues all of them. And it is basically to the point where people treat certain tools like tape measures in the wood shop as a consumable. There's something that just disappear and you have to get new ones. And hopefully that's something that we can change because that feels wasteful. And I think I wouldn't even describe it as weaknesses, but rather places that need more thought and more consideration and more improvement. And I think the way that tools are kept in the space and maintained is definitely one of them. Printers are also tools that need long-term maintenance. They do break in larger ways than just small little print fails. And people need to be ready to take care of them and to do maintenance from the bottom up. And that's something that we've actually designed into what we're doing. Calum right now is working on assembling the fourth printer. We bought 4 of these Pruses, and only 3 of them we got pre-assembled, and the final one was a kit. And he's working on assembling that, basically all of the steps to create it right now so that he knows it inside and out, and we'll know how to fix it next year and into the future. Yes?
If someone wants to use a printer or a laser cutter, some piece of equipment that they're not familiar with, who would be available, or how would one find someone available to give the instruction?
So we have an email for the makerspace that is visible by Rosie as well as the space heads, and that is a great way to get in contact with people. And right now we're working on finalizing that kind of education and curriculum for how to do that. So I think there will be more information coming on that soon, is how I'm going to answer that.
Mine was similar to Naomi's in that I was curious if there's been discussion on how to really encourage freshmen and sophomores to get involved, seeing that it would take some time to learn the equipment and then make, like, you handing it off to Lewis is wonderful, and then that would need to continue if what Todd and Gil are talking about is being maintained. I didn't know if there's been talk about like, specifically the younger set of students.
Mm-hmm. Yeah, I think that's really important. I dream of a future where this integrates into some sort of class in some way, in a way that people are really encouraged to use and interact with the space, and there's a kind of formal way that teaching can happen. Because I think in the long term, that's how you achieve that goal of keeping it clean and keeping people know how to use it, is that there is a formal introduction to it and how it's used. Travis.
Fold it into Cola Jack.
No. All right, any other questions? Thank you all so much.